Hey there, tech enthusiasts. Welcome to How It Clicks today. I'm diving into the secret life of calculators, those handy little devices we often take for granted. Ever wondered how they take your input, process it, and spit out the answer? Let's break it down. First off, when you press a button, you're actually sending an electrical signal into the calculator. These buttons aren't just simple pieces of plastic. They're connected to a grid of circuits underneath. This grid sends your input to the microprocessor, the brain of the calculator. Now, about the microprocessor, it's a tiny chip embedded in the calculator. Think of it as a mini computer, executing instructions at lightning speed. When you hit a button, a specific binary code is generated and sent to this chip. It's the microprocessor's job to decode this signal and understand which digit or operation you've entered. Let's say you input go 2 plus 3. When you press 2, the microprocessor receives a binary code for 2. Next, pressing plus sends another unique binary code representing the addition operation. And finally, pressing 3 sends the code for 3. Here's where the magic happens. The microprocessor processes these binary signals using something called an ALU, arithmetic logic unit. The ALU is designed to perform basic arithmetic operations like addition, subtraction, multiplication, and division. For 2 plus 3, the ALU fetches the binary codes for 2 and 3 and performs the addition operation. The result is then converted back from binary to a decimal format that you can understand. This entire process takes just milliseconds. But wait, there's more. Calculators don't just perform addition and subtraction, they handle complex functions like square roots, trigonometry, and logarithms. For these operations, the microprocessor relies on pre-programmed algorithms, step-by-step procedures to solve specific problems. Take the square root of 16, for example. When you press the square root button, followed by 16, the calculator uses an algorithm called the digit-by-digit method to find the answer. The algorithm breaks down the problem into smaller steps the microprocessor can quickly solve. That's how you get 4 as the result almost instantly. Finally, the output. Once the microprocessor has the result, it sends this information to the display driver. The display driver then converts the data into a format the LCD screen can show. That's how you see the number 5 or 4 or whatever your result is right there on the screen, and there you have it, the secret life of calculators. From pressing a button to seeing the answer, it's all about electrical signals, binary codes, and lightning-fast processing. Next time you use a calculator, you'll know just how much tech is packed into that little device.